All right, so here's an example where we're going to be answering, some more specific questions. You might see questions phrased uh, regarding z-scores and finding values that are a certain number of z-scores away. Um, and so that's what this example is meant to demonstrate. Okay. So a fifth grade teacher was interested in the mean and sample standard deviation of the ages of her students. A sample of 20 fifth grade students were recorded. Okay, so these are the ages. Let's see here. Okay, yes. So there's four parts to this question. Part A is to find the mean and standard deviation on your calculator. Part B is find the value that is one standard deviation above the mean. Part C is find the value that is two standard deviations below the mean. Find the values that are 1.5 standard deviations from the mean. Okay, so part A is to find the mean and the standard deviation. So that we can get just by putting into the calculator, okay, which is what I've done here and here. And so if we look at the list editor for both statistics app here, okay, so I put in the values with frequencies, and now I can just go into the Texas Instruments, hit the stat button, do one variable stats. List one is my list of unique datums. My frequency list is in list two. Go to calculate. Okay, and there's my mean, 10.525, and my standard deviation. Okay, that's a um, pretty significant decimal there. Okay, and over here, so I can go up to the stats tab, click OK. I want to go down to sample mean. Here we go. Now I'm going to go ahead and store that in capital M to stand for mean. And then the sample standard deviation, I'm going to store that too in lowercase s. Okay, so let's come back over. So this is where we get this value of 10.525 and the standard deviation being 0.71589. So in part A, since the mean and the standard deviation are the final answer for this part, one can round to one decimal place more accurate than the data. So, our data only goes to one decimal place at most. So we're just going to go ahead and round to two decimal places. Okay. Part B is find the value that is one standard deviation above the mean. Okay, so when we talk about one standard deviation above the mean, what we mean is, let's see here. So one standard deviation is equal to a z-score of 1. Okay, so one standard deviation, let me see here. Let me do it this way. One standard deviation is a z-score of 1. And when we say that we're looking for one standard deviation above the mean, that means that our z-score is going to be positive. And then find the value means we need to find x. So I wrote this formula down here, but I think what I should have done is maybe written it more like that. Okay. So our mean was 10.53 plus a z-score of 1, should be a positive 1, because we want a value above the mean. We have a standard deviation of 0.72. Now, I'm going to do this calculation, and I don't remember when I wrote this, if I used these fully accurate values or if I used the rounded values. So right now I'm going to do the fully accurate values to see if it comes out a little bit different than 11.25. So let's take a look. Okay, so we need to put X bar. So I'm going to hit variables, stats, okay, X bar plus, okay, positive 1, Z, and then that's going to be times the standard deviation. So I'm going to hit the vars button, go down to statistics, go to SX, and hit enter. Okay, and I get 11.24. So this value that I put in here, that is using rounded values. Okay, so this should actually be 11.24. This is if you use the non-rounded values. So let me rewrite this part on the right. I'm sorry. Okay, this result is what we get here. But over here, let me write this a little bit more intelligently. All right, so this was actually 10.525 plus 1. And I'm going to put 0.71 and keep going to show that I used the more fully accurate version there. And what we get is 11.24, and it keeps going. Okay. All right, but even though it keeps going, after the second decimal place, it's a 0. So if we were rounding this to 2 decimal places, it would be a 0.24. Okay, Microsoft Word is paused here. So, this actually just kind of demonstrates the dangers of rounding your numbers in the middle of your calculation instead of waiting until the very end to round. So this difference, of 1/100th on an online homework question could be the difference between getting it right and getting it wrong. Okay. So just be aware of that. All right, so find the value that is 1 standard deviation above the mean. So we have a mean of 10.525 years. That's the average age of the 5th grade students. So the age of a student that's 1 standard deviation above this is 11.24 years. Okay, now it says find the value that is 2 standard deviations below the mean. Okay, so 2 standard deviations below the mean. Okay, so first of all, 2 standard deviations is going to imply a z-score of 2. And because it's below the mean, this is going to be a negative z-score. So our value of z is going to be -2 in this case. And then find the value, that's x. Okay, so I think this answer too is based off of these rounded values. So I'm going to do the same calculation. Let me put 10.525 plus, now we want to put in -2 because we want 2 standard deviations below the mean. And then S is 0.71 dot dot dot. All right, so now I'll do this calculation this time with NumWorks. So let me go home, go to calculation. Okay, so I can't reference the variables like before, but I did store the sample mean in capital letter M. So I'm going to hit Shift Alpha M plus a z-score of -2 times the standard deviation, and I think I put that in lowercase s. All right, so I get 9.0932. So 9.0932, and it keeps going. So in this case, using rounded values didn't make a difference in the answer, but you can't always predict that. So it's always best to use, you know, like as fully accurate values that you can using the calculator, and only round here at the very end. Okay, part D is to find the values that are 1.5 standard deviations from the mean. So because they're not saying above the mean or below the mean, it's saying 1.5 standard deviations, plural, from the mean. What they mean is 1 point standard deviations both above and below. So we're going to have a positive z-score of 1.5 because that means 1.5 standard deviations. And we're going to have a negative z-score of -1.5, which means 1.5 standard deviations below the mean. Okay, so let's do those calculations, maybe on both calculators. So here we're going to have x bar minus, I'm sorry, plus, we'll make this a positive 1.5 times, so variables, I'm going to hit 5, then I'm going to hit 3. Okay, so yeah, we get a different answer, 11.598, and it keeps going. So if we do it fully accurate, we get 11.598, and it keeps going. So that'll end up being rounded to 11.60 years, okay, for this first one. So a little bit different there. And let's go here to NumWorks. So I'm going to have the mean plus a negative 1.5 times lowercase s. And we get 9.451. So I get 9.451, and it keeps going, which we would get 9.45. So this did not produce an answer that was different than if we had used rounded values during our calculation. But this is a good example of, actually why you should not do that. So finally, what I want to say about this is that when it talks about looking for something that's 1 point something standard deviations away, hopefully what you just saw was that the number of standard deviations is actually equal to the z-score. Okay, so for example, 2 standard deviations is equal to a z-score of 2. It could be +2 and -2. Okay, if you want a value that's 3 standard deviations, then that's going to be z equals 3. All right. So that's a little bit of the take-home connection here with all of this, but also providing an example of doing some of these calculations. All right, let me know if you have any questions.